Okay, shall I everyone? Okay, now write down the new topic, that is what? Spring balance. Spring balance. Okay, spring balance. Shall I start now? Okay, now spring balance is nothing but an instrument that generally measures the mass. Generally, we use this instrument to measure the mass. Okay, in reality, it is measuring the mass, or it is in measuring something else. From something else, we are converting this in terms of mass or not. Let us try to understand this. Okay, before starting the topic, let me ask you one thing about the weighing machine. Okay, what do weighing machine measures? Normal or the mg? It measures what? Normal. Are yes or no? It do not measure the mass. Yes or no? We already learnt about that. Are got my point? Acha, one more thing. Normal is always equals to mg on the weighing machine, or it changes? It changes. It depends on the direction of what? Acceleration. If acceleration is in the upward direction, we know that normal will be greater, mg will be smaller. Similarly, if acceleration is in the downward direction, we know that mg will be greater compared to what? Normal. Okay, same concept, same type of concept we are learning in what? Spring balance. Okay, spring balance is not measuring the mass. Okay, let us try to understand this in this way. Okay, consider a boy or Chinnamma. So here is Chinnamma. Chinna brought what? Chinnamma brought what? One spring. Consider here is one spring, and the length of this spring, let's say 1 meter. So length of this spring, that is what? Natural length of this spring is how much? 1 meter. And what is the value of spring constant? Let's say 100 Newton per meter. Okay, so we already know the basic properties of this spring. Always we measure the distance or the expansion from the natural length first thing, and this spring is what? Massless. Are you yes or no? Okay, what she did is she made one marking over here. Why? Because at the natural length x is equals to 0. X is 0 at the natural length. Are you yes or no? So this is the position of what? Natural length, and x is equals to what? 0. What she did next is she added one or tied one string to this. She added what? Or tied one string. This string is also massless, we know that. Are you yes or no? And what the next thing she did is she added one more hook. Hook-like structure. Okay, to tie something else. I got my point. So what Chinnamma brought? Chinnamma brought 1 meter natural length spring, and whose spring constant is what? 100 Newton per meter. Then next what she did is at the end of the natural length, she made a marking x is equals to 0. Why? Because at the natural length, expansion or the compression, that is x value becomes what? 0. We know that. Okay, she added one more string and one hook to that. I got my point. Okay, what she did is she brought 1 kg, or she tied over here 1 kg block on this string. Okay, so what is the mass of this block? 1 kg. I got my point. Okay, now will it stay over here only, or will it go to the mean position? Obviously it will be going to the mean position. Consider it reaches to the mean position here. So at the mean position, we know that kx is always equals to what? Mg. Kx is equals to what? Mg. From here, can I calculate the expansion, the value or the amount of expansion in the spring? Yes. So kx is equals to what? Mg, and x is equals to mass is how much? 1 kg. Na? So 1 kg, that means 10 upon 100, that is what? 0.1 meter expansion. Are yes or no? Okay. If she took or replaced this 1 kg to 2 kg, obviously we can calculate the amount of expansion. That means 20 upon 100, that is 0.2 meter. Are yes or no? If she changes the mass to 3 kg, obviously she will be knowing, getting what? The value 0.3 meter. Okay, so Chinnamma made this instrument. What she did? She know the value of what? Spring constant. She know the value of what? Natural length. Natural length is not more important, but value of k is important. Okay, and she also know that with 0.1 meter, how much is the amount of force? That is what? 10 Newton. 10 Newton in the downward direction. At this point, obviously N will be acting, that is what? 10 Newton, and Kx is nothing but equals to what? 10 Newton. That is nothing but your tension now. The amount of tension or the value of spring force, that is what? 10 Newton. Are yes or no? We know this. Now, already she made one instrument. Okay. I went to her. Okay, and I brought one block, and I don't know the value of that block. I got my point. So I went to her, and she has hide one block over here. Here is the marker. Here is the string, and here is the hook. Same value. K is equals to what we have taken. K is equals to 100 Newton per meter. Natural length of this spring is nothing but 1 meter. Okay. I got my point. At this point, expansion is what? 0. I got my point. Okay. I don't know the mass of that block. So what I did is I hanged this one or tied this block, and I don't know the value of that mass block. Okay. This pointer, at this point x is equals to 0. What I found is, what we both found is, the expansion or the movement of this marking point went from here to here. Okay, and it went to 0.5 meter. How much is the expansion in the spring? 0.5 meter. Okay, now who knows this? With 1 kg, what is the expansion? 0.1 meter. And with 2 kg, what is the expansion? Obviously, it will be 0.2 kg. With 5 kg, the expansion will be 0.5 meter. So, Chinnamma said that what you have brought the block is of 5 kg. Yes or no? With this 5 kg, obviously we know that if this one is having a 5 kg, how much is the amount of force? That is what 50 Newton is acting in the downward direction, and tension value from here we can say that is what 15 Newton. That is nothing but your force, that is Kx, spring force. Okay. So in reality, spring balance is not measuring the mass. It is measuring the amount of tension. Because of this tension, this marking is going in the downward direction. With that, we found that one more instrument, that is what? Spring balance. I got my point? Yahan tak samajh mein aa gaya? Okay. Now in reality, what is happening is, spring balance look like over here. I will draw the diagram of the spring balance now. Okay. So spring balance look like this. Consider here is the spring and here is the end of the spring. Okay. And wherever it is ending over here, the marking starts from here. Okay. On one side over here, you will be finding a scale in terms of Newton. That is what? Force. Okay. One side you will be finding a scale of what? Newton. That is amount of what? Force. On the other hand, you will be finding in terms of kg or in terms of what? Grams also. Okay, so here is one more scale over here. So two scales are being represented on what? The spring balance. Okay. Now, a string is being tied and this one is being hanged to a hook. It is being tied to a hook, and from here, if you add a mass, let's say I am adding 6 kg. If I am adding what? 6 kg, I don't know. Consider I don't know the mass of this block. I don't know the mass of this block. Over here, what I found is this marking. What is the marking over here now? So this one went to what? A 60 Newton. Let's say it reached to what? 60 Newton. How much? 60 Newton. So this marking is over here. From here to here is the displacement of that spring or the expansion of this spring. And what we found on the Newton side, that means force side 60 Newton. On over here, I will be finding over here is what? 6 kg. Okay. So from there, I can say this block is of 6 kg. I got my point. But the reading of this spring balance is being represented in terms of what? 6 kgf. How much? 6 kgf. That is kg force. I got my point. So it is nothing but 6 kg only. What we are defining for this spring balance, we need one more unit for the separate instrument now. So what is the unit of this spring balance? Kgf. And 1 kgf is nothing but 9.8 Newton. 9.8 Newton or nearly equal to 10 Newton. We generally take G value is equals to 10 now for easy understanding. So 10 Newton. So 1 kgf is equals to what? 10 Newton. But one more thing we need to understand. Consider this is dependent on G. we are saying 1 kgf is equals to 9.8 Newton. I got my point. That means approximately equal to what? 10 Newton we are saying. So what is this G value is of 10 Newton? Where we are measuring? We are measuring this on what? Earth. I got my point. So consider like this. Consider over here. I made one block of 20 kg. Okay. 20 kg is the reading of what? One block on the earth. How we are calculating the reading? So let us try to understand the reading of what? Spring balance. So reading of a spring balance is nothing but what we are doing. How much is the force we got? 60 Newton. Na? So from 60 Newton what we are doing? 60 Newton divided by this G. Are yes or no? mg is how much over here? mg will be acting in the downward direction and kx is acting in the upward direction. That is nothing but your tension. So spring balance is given by mg upon g. mg upon what? G. What is the mass? 6. What is the value of g? No, 10. So 6 into what? 10 upon 10. Then we are getting what? 6 kgf. This is how we are getting the reading. So mg upon g. Over there normal upon g na? Yes or no? So over here what we are getting what? mg upon g. I got my point. So for example, now if I take the same amount of the block or the same mass of the block, let's say 6 kg, we are taking 6 kg now. So 6 kgf we got on what? Earth. If I take the same amount of block or the same block on the moon, we know that G value is different. G value of the moon is nearly 1/5 of the earth. Yes or no? 1/5 of the earth means approximately equal to 2 meter per square second. Let's say G of moon is equals to 2 meter per square second. Okay, if 2 meter per square second is the acceleration due to gravity on the moon, then if I want to calculate the amount of the reading of what? Spring balance, then it is dependent on what? G. But over here, this G is always universal constant. Okay, so how we are writing for the moon? The block mass. Okay, how much we got on earth? That is what? 6 kg now. 6 kg on what? Earth into G of moon upon G of earth. Understand? Okay, now substituting the value 6 into 2 upon 10, that is I will be getting 2 kgf on the moon. Same block 6 kg on earth. Same block if we measure on the moon, we got what? 1.2 kgf. So it depends on what? G. Spring balance is completely dependent on what? G, and it is being derived for the G on the earth. That's the reason this G in the denominator is universal constant. I got my point. I will take one more example to explain you. Abhi likho mat. Don't write anything. Okay, consider I measured 100 kg on earth. 100 kg on what? Earth. I want to calculate the amount of what? Mass on the moon. Okay, so reading on earth, reading on what? Spring balance on this one is for earth is nothing but mg of earth upon g of earth. Okay, what is the mass? 100. So 100 into 10 upon 10, that is nothing but 100 kgf. This is for the earth. Okay, if I want to measure on the moon, so spring balance reading on what? Moon, then I will be writing mass on earth or any planet. Mass we are calculating for the earth, so mass on earth into G of moon upon G of earth. I got my point. Okay, so mass of the earth is how much we got? 100 into G of moon is what? 2 divided by 10, so it is nothing but 20 kgf now. Okay, they can frame like this. 100 kg is found on Jupiter. 100 kg is found on what? Jupiter, and consider G value of Jupiter is 100. Okay, so 100 kg is measured on what? Jupiter. is the reading kgf, and g of what Jupiter is what 100. I want to calculate on the Earth. Obviously, I will be writing what now mass on the Jupiter, that is what 100 into g of what Jupiter, g of what Jupiter, then g of what Earth, g of what Earth. That's it. So this is the basic funda. Then you can calculate one equation like this. Now just write this one. Reading on, can consider we are discussing for moon. Reading on moon upon reading of what Earth, which is nothing but g of moon upon g of Earth. G of moon upon g of Earth. So reading of moon, g of moon, both will be in the numerator, and g of Earth upon g of moon. I got my point. So this is the equation what you need to understand. यहाँ पे देख लो रे, this if I divide these two, g of Earth get cancel na. So this is the g of Earth divided by g of moon. So what is our equation then? If I flip on that, I will be getting that only na. This mass and this mass get cancelled. Are yes or no? So what we are substituting? G of Earth, G of moon, G of Earth. Reading on Earth, reading on moon. From here we can calculate with anyone. I got my point. So what I said on how much is the measuring of what? 100 kg, na? Okay. So on Jupiter what we found? 100 kg. So reading on what? Jupiter upon reading on of Earth. Okay. So G of Jupiter upon G of what? Earth. Okay. So how much is the reading we got on Jupiter? 100 kg. So 100 kg we don't know reading of what? Earth, which is equals to G of Jupiter, let's say 100 upon what? 10. So this one get cancelled. So I will be getting reading on Earth is what? 10 kg. I got my point. 10 kgf. In reality we should be saying 10 kgf. Kg force. Itna samajh mein aaya. So these are all basic things. Only you need to remember this equation. I got my point. And what is the unit for spring balance? kgf. I got my point. Okay. Now you can explain this. Shall I know? Okay. Now consider example number 1. Tell me the overall answers for these two. Consider here is a string and over here is your spring balance, and to this one block is been attached 10 kg. 10 kg. Tell me the reading in the spring. Obviously you will be telling what? How much? 100 kgf or 10 kgf? 10 kgf. Okay, 10 kgf. And 10 kgf, how much will be the amount of force it is showing over here on the Newton side? 100 Newton. Are yes or no? Similarly, tell me for this one. Consider here is a pulley and one spring balance is been attached over here, and this one is being fixed. And consider here is one block, and this block is of 20 kg. What will be the reading? Obviously, tension is the reading, na? Are yes or no? So over here it will be showing what? Kitna aega? 20 kg? Okay, very good. So over here you will be finding 200 Newton. Over here is tension is equals to 200 Newton. Now tension on the force side you will be getting what? On the Newton side you will be getting what? 200 Newton. Are yes or no? Tension will be same, na? Massless string. So 200 Newton, and what will be the amount of force? That is what? 20 kgf. Are yes or no? Now tell me one more question. Example number 3, and consider it is being framed like this. चुप करके जल्दी जल्दी डायग्राम्स बनाओ. Okay, and over here is one pulley. Over here is also one pulley, and over here consider like this. Here is your spring balance, and here is one mass. Here is also one mass. This one is of 10 kg. This one is also 10 kg. Both are 10 kg. Okay. Question is again, find the reading in the spring balance. Okay. उसको try करो जल्दी. Okay. Shall I कितना है? सभी का 0 आ रहा है. चलो देखते हैं. Shall I? Okay. Now mg over here will be 100 Newton. Are yes or no? Obviously over here tension will be 100 Newton. Over here mg is equals to what? 100 Newton. Over here tension is equals to 100 Newton. Are yes or no? This system, can I say, will stay at equilibrium? There will be no acceleration at all. Okay, now what is the amount of tension over here? Tension from here to here is 100 Newton. Obviously this one is 100 Newton. Are yes or no? Now listen to me. Spring balance is massless. Yes or no? Inside there is a spring, and that spring is what? Massless na. Uska upar ka box mat dekho re. Okay, this is the general representation of what? Spring balance. Okay. This string is massless, this string is also massless. Obviously, what is the tension throughout this whole setup? 100 Newton. If 100 Newton is the amount of what? Force, then what will be its reading? 10 kgf. So, what is the reading over here? That is what? 10 kgf. I got my point. That all you need to divide by G na. 100 is the Newton of the force. So, if I ask you now, spring balance is measuring the amount of what? Mass, or it is measuring the amount of force? It is measuring the amount of what? Force. By that force, what we are doing? We are dividing that by G. I got my point. So, how much is the force in the spring or the string or the hole on the setup? Is 100 Newton. 100 Newton upon G, and G how much we are taking? 10. Obviously, it will be represented by 10 kgf. What is the reading on the spring balance? 10 kgf. Okay. उसको थोड़ा acceleration में कर लो. Consider like this. Same setup, and here is one pulley, and here is also one pulley. Over here you got 20 kg, and over here you got what? 10 kg, and this one is being tied with a spring balance here. Question is again the same. Find the amount of reading in this spring balance. Okay. Usko equilibrium mein, that's the reason we said 100 is the Newton of the force. Now it is not stay in the equilibrium. Obviously this 20 kg, 200 will be acting in the downward direction. Over here 100 Newton is acting in the downward direction. Acceleration will be, yes, very good. Chalo try karo jaldi. Try this. Okay, shall I? Okay, आ गया सभी का? Okay, चलो देखते हैं. Let us check your answer. So tension will be over here in the upward direction. So for 20 kg block, what should be the equation? Acceleration is in the downward direction. Who will be greater? 200 will be greater. So 200 minus of t is equals to what? 20a, and this is your equation number 1. Obviously that one will be going with the same acceleration in the upward direction. So over here acceleration is in the upward direction. T will be in the upward direction. Who will be greater here? T will be greater. So T minus of what? 100, that is equals to what? 10a. This is your equation 2, adding equation 1 and 2. That's it. Yahi kiya na? So this T and T get cancelled. So this one becomes 200 minus of this 100, which is equals to what? This becomes what? 30a. Our acceleration is what? 100 upon what? 30 meter per square second. Yes. What we need to calculate? We need to calculate what? Tension. Substituting anything in any equation. So I am substituting in equation 2. So T minus of 100, which is equals to 10 into A, and A is what? 100 upon 3. Yes or no? Sorry. 10 upon 3. Thank you. So what will be I getting over here? That is what? 10, 100 upon 3. So tension is nothing but 100 upon 3 plus of this 100. So T is equals to 400 upon 3. Yes or no? This is the amount of what? Tension. I asked you to calculate what? Amount on the reading na. All you need to do what? Divide this by 10. Itna to sabhi ka aaya. Okay. Then what will be the reading? Reading is nothing but reading in the spring balance is nothing but tension. That is what? Force upon what? G. Force upon G. What is the amount of force we got? 400 upon 3. So reading in the spring balance is nothing but 400 upon 10 into 3. That means reading in the spring balance is nothing but 40 upon 3 kgf. समझ में आ गया ना? Let us add with the pulleys this one. Okay, चलो इतना लिख लो पहले. Okay, next example. So थोड़ा सा अच्छा बनाओ. Okay. So let us substitute in constraint. Okay, how many questions we have done in constraint and the moving pulley blocks now? All you need to remove one string and add one spring balance on any string. Okay, That's it. You can find, all you need to find what tension. From the tension divided by 10, you will be getting the reading. Okay. थोड़ा सा अच्छा बनाएंगे question. So let's select this. Consider here is one pulley and over here is one block, and let's say this one is having 10 kg. Okay, 10 kg, 1 kg, कुछ भी ले लो रे. Okay, and then this one is being tied over here to a pulley like this. And this one is being tied over here. And this one is been attached to one more pulley, and over here one more pulley, over here one more pulley, then this one is going and fixed over here, this one is being hanged over here, and here is one more mass. Let's say this one is 20 kg. अच्छा बना रहा है diagram. Okay, here is also fixed. Now, where should I apply the spring balance? इधर तो काटो, इधर तो काटो. Wherever you want to substitute the spring balance, you can substitute. Let's say spring balance is attached over here. This is your spring balance. Question is same. Find out the amount of what reading. What is the reading in this spring balance? Okay. How many equations? अबे 3 equations आएंगे ना. One tension for this one. This one for tension 2. Second law इस पे लगाओ, second law इस पे लगाओ. Where you will be finding? How you will be finding? Yes, constraint. From the constraint, you will be finding the third equation. Substitute and get me the value of what tension first. Then after calculating the tension, just divide by 10. Okay, come on. Shall I know? So I will consider. नहीं होगा रे. ये 20 kg है, इसको नीचे लेके जाओ, इसको ऊपर लेके जाओ. I will do like this. So acceleration of this one, let's say this one is your A2 and this one is going in the upward direction with what A1 acceleration. Okay. Now substituting the values. Over here 200 Newton is acting in the downward direction. Over here 100 Newton is acting in the downward direction. Tension will be acting in the upward direction. Let's say this is your T1 or either tension लिख देंगे. Okay. Now calculating the what is the acceleration of this pulley. Okay. First thing, we know that the amount of the tension values remain same or different. Tension value will be same. Okay. Now substituting the values and tell me the acceleration. So if this one is T, obviously this one will be T. Over here you will be getting what 2T. Are yes or no? If this one is 2T, obviously over here 2T, over here 2T, over here 2T, over here is also 2T, and 2T, over here you will be getting what 40, over here you will be getting what 40. Sabhi ka hai equation? Okay. Now writing the equation for 10 kg. For 10 kg, what is the equation we will be getting? T will be greater, na? So T minus of 100, which is equals to 10A1. This is your equation number 1. And for 20 kg, 80. Aaya sabhi ka 80? Okay, very good. So for 20 kg, I am writing the equation and acceleration is in the downward direction. So 200 minus of 80, which is equals to what? 20A2. This is your equation number 2. Third equation, constraint. Very good. Now, this one is a moving pulley, this one is fixed, and this one is going in the upward direction. Obviously, this pulley will be going with what? A1 by 2. Are yes or no? AP is equals to A equation lagao. AP is equals to A1 plus of A2 divided by 2. भूल जाओ, नया पढ़ते जाओ, पुराना भूलते जाओ. Okay, now acceleration of this pulley, this consider is 0. So this one is 0. A1. A1 is how much? A1. So acceleration of pulley is nothing but A1 upon 2. अरे got my point? इसको L A ले लें, इसका नाम दे दे B. Okay. So what is the acceleration of B? B is nothing but A1. So A1 by 2. This one will be going in the upward direction. We got positive. So this one will be going in the upward direction by A1 by 2. I got my point? Okay. Then next, if that one is going by A1 by 2, that means this point is going by A1 by 2. This is a single string. Now apply the third method of the pulley block system. Okay. So this one is a fixed pulley. So how many points are there? First point number 1, point number 2, 3, 4, 5, 6, 7, 8, 9, and that one is what? 10. All should be, sum of all should be equal to what? 0. So this one is going with what? A1 by 2. A1 by 2 plus this one is 0, 0, plus of 0, plus of 0. This one will be going in the downward direction or upward direction. It will be going in the downward direction. If this one is going in the upward direction, length decreases. This should be minus. Yes, okay. So now this one is going in the downward direction, length increases. So this one will be equal to how much? A2. A2 likh do. Okay, 0 plus of 0, then this becomes what? Plus of how much? This one. This one and this one will be going with the A2 acceleration now. So A2 plus, so A2 plus of A2. Then this one is fixed to this pulley, so 0 and 0. So 0 and 0. Again, this one is tied to this block and going in the downward direction, length increases. So again, this one is positive, A2 plus of A2. That one is fixed, so 0 plus of 0, which is equals to what? 0. Now, how many A2s are there? 1, 2, 3, 4 A2s are there. So, minus of A1 upon 2 plus of 4 A2, which is equals to 0, or I can write this as A1 by 2, which is equals to 4 A2. Can I write like this? Or A1 is nothing but 8 A2. This is the third equation. Equation number 3. Get A1 and A2. Get A1 and A2. That means A1 will become T minus of 100 divided by 10 and A2 will be 200 minus of 80 divided by 20. Substitute in that and tell me the value of tension now. Okay? Okay, stop discussing. I will do the remaining part. A1 is equals to T minus of 100. T minus of 100 upon 10 and A2 is equals to 200. बोलते जाओ रहे 200 minus of 80 upon 20. Are yes or no? Substituting in equation number 3 and A1 is equals to what? 8 A2. A1 is equals to T minus of 100 upon 10, which is equals to 8 into इसको ऐसा कर लो रे, easy हो जाएगा. This is A1 by 2 ना. So A1 by 2 is equals to 4A2. Okay, why? Because I am getting 2 to 20 can be cancelled now. So A1 is how much? T minus of 100 upon 20, which is equals to 4 into 200 minus of 80 upon this one is 20. This 20 and this 20 get cancelled. Are yes or no? So T minus of 100, which is equals to 800 minus of 32T. So this becomes 900 and 900 and this 33. So 33T is equals to 900 or T is equals to what? 900 upon 33 newtons. सभी का आया? Okay, very good. तुम लोगों को भूल मत जाओ यार. Okay. You will be getting 3 equations here. One for the first block, second block, tension for the second block depending on the acceleration. Third is obviously from the constraint ना. Okay, याद रखो बेटा, इसको प्रैक्टिस करो. Okay, next example shall I? थोड़ा ध्यान से करना. Okay. Now the question is like this. Consider here is the lift. Here is the lift. Okay. Inside the lift there is a weighing machine. Okay, here is the weighing machine. On that weighing machine, Chinnamma is standing. Okay. Now on Chinnamma, what we did is we hanged one spring balance. She is being hanged on a spring balance to her neck like this. Pasi ka panda. Okay. Now the question is, actual mass of the Chinnamma, actual mass of this person, what we found is what? Actual mass is equals to 100 kg. Okay. And lift is accelerating in the upward direction by A. Lift is accelerating in the upward direction by A and weighing machine is reading a mass. Weighing machine reads a mass of what? Let's say 60 kg. Weighing machine is measuring how much? 60 kg. Okay, थोड़ा अच्छा नहीं आएगा ना आंसर. Let's say 80 kg. Weighing machine is reading how much? 80 kg, and here is your spring balance, and spring balance is reading a mass of, let's say, 60 kg. Okay. First calculate how many forces are acting on that person. Okay, obviously mg will be acting in the downward direction, normal will be acting in the upward direction. Whose reading is this? Weighing machine reading is what? 80 kg. Are yes or no? Take g is equals to 10 only. Okay, and spring balance reading is what? 60 kg or 60 kg f. 60 kg f, it is nothing but a unit. Okay, that is nothing but your 60 kg only. Question is, find the acceleration of the lift. Question number 1. Question number 2, write down. Question number 2, if acceleration is doubled, if acceleration is what? Doubled, then what will be the reading? What will be the reading in weighing machine and in spring balance? Spring balance. एक bracket बनाओ. Note, height of the person never changes. Height of the person never changes here. Okay, this height. This is the height of the person is not changing. If the person, maybe she is sitting and the person height can be changes. Okay, वो उठेगी तो height change हो जाएगा ना. Okay, so question आ गया समझ में. First calculate the acceleration, then double the acceleration, check the value of the forces, which forces is changing and which forces are not changing. Okay, now. Okay, acceleration कितना है रे? 2 आया ना, 2 को 4 कर दियो. Okay, very good. चलो अभी सुनो इधर. Stop writing and listen to me. So, how many forces are acting? Consider here is the girl, and this girl is having actual mass is how much? 100 kg. And what is the reading in the weighing machine? That is what? 80. That means weighing machine reads what? Normal or the mass? It measures what? Normal. So, normal will be acting on the person in the upward direction, and spring balance is also in the upward direction. mg will be acting in the downward direction. Acceleration is in the upward direction. Can I say that this is the true equation? And can I write this as nothing but tension in the spring balance? Okay, what will be the equation? N plus of T minus of mg is equals to ma. Sabhi ka ye aaya. N plus of T minus of mg is equals to ma. Are yes or no? Okay, substituting the values now. N is nothing but weighing machine reading. It reads what? Normal. So how much? 800. That means 800 plus of tension. How much is the given tension? 600. Very good. So 600 minus of what is the mg, mass of the actual person? 100. So that means this one becomes what? 1000, which is equals to 100 into A. Can I say that? Okay. So this becomes how much? 1400 minus of 1000. That is 400. Abbe 4 aa raha na? Okay. So this is nothing but what? 80, and this is nothing but 1400 minus of what? 1000, which is equals to 100A. Okay, this becomes what? 400 upon what? 100. That acceleration is nothing but your 4 meter per square second. 4 आ रहा बेटा, 2 नहीं आएगा. Okay. Now, नीचे क्यों लिया? Tension. This spring will be having force in the upward direction ना बेटा. ये force tension ऊपर लगेगा. Are yes or no? He is standing on the weighing machine. Normal will be acting in the upward direction. Are yes or no? mg of this person will be acting in the downward direction, na? So n plus of t, acceleration is in the upward direction. That's the reason n plus of t minus of mg. Lift अगर नीचे जा रही होती, then we will be writing the equation as mg minus of t plus of n. Are yes or no? So question is what? If the acceleration is doubled, if the acceleration is what? Doubled, then what will be the reading? Then what will be the reading in the spring balance and in the weighing machine? That is the question. If acceleration is doubled, so acceleration is doubled. And one note is also given, height of the person never changes. Height of the person never changes. But what will be the changes happening? What is our equation? If the acceleration is doubled, even though our equation will be n plus of t minus of mg, which is equals to m into 2a. This one will be our equation now. Okay, now the question is, will n changes, will t changes, or both changes? Okay, now listen to me. If height of the person is also changing, then t also changes. If height of the person is not changing, then t remains fixed. Why? Because he is standing on the weighing machine and he is tied to the spring balance also. Are yes or no? So this height is not changing. And question में कुछ तो एक देगा. Either normal will be changing or either this t will be changing. If height is not changing, who is not changing? Then tension is not changing. If height is changing, reading in the weighing machine remains fixed. If the question is being framed like this, if the acceleration is doubled and weighing machine does not show any changes in the reading, then who is changing? Tension will be changing. Are yes or no? Both changes, you can't do the answer. There will be multiple options ना. इसका भी 100 बदलेगा, इसका भी 100 बदलेगा. Both will be changing to 100, 100. Both will be changing to 200, 200. Or one will be changing to 200, one will be changing to 100. Many possibilities will be there. Are yes or no? So better they will provide either n will be changing or either t will be changing. Okay. If height of the person is not even given, consider there is no note has been given. Height of the person is also not. Even he is standing. Even he is standing. The person is standing. Obviously, the whole question is being framed on he is standing. That means height of the person never changes. We know that. Expand to nahi hoga na height. Are yes or no? Then who is changing? Normal will be changing. Tension will be remaining constant. So now n dash plus of t minus of mg is equals to ma. So n dash we don't do plus of. This is the reading in the spring balance. How much? 60 Newton. So, sorry, 60 kg of that means 600 Newton minus of mg, that is what 1000, which is equals to mass is what 100 into 2 times of 4. Are yes or no? Then n dash is equals to, this becomes what 400 minus 400 goes over there. It becomes plus 400 and 400 and this one it becomes what 18, that's 1600. So this becomes what minus of 400, which is equals to, that becomes what 800, 1200 aa raha hai. Are yes or no? So n dash is nothing but 80 plus of this becomes what 1200 Newton. If 1200 is the Newton, then divide that by g. Again you will be getting the mass in the reading in the weighing machine. So what is the mass? So n dash reading in what weighing machine reading is equals to force upon again g. So weighing machine reading is nothing but 1200 upon 10. Obviously now the weight is what 120 kgs. Are yes or no? If it is accelerating in the downward direction, you know what to do. Are I got my point? So write down, this one will be the last question on this topic. Let us move to the next topic. Okay.